Hi everyone, let's start by looking at what we'll be building in this video. So here we have a simple setup to measure distance using Raspberry Pi and ultrasonic sensor. And we're building our own simple circuit using resistors to convert 5 volt coming out of ultrasonic sensor's echo pin to 3.3 volt that's going into GPIO for Raspberry Pi. The reason we need this circuit is GPIO in Raspberry Pi works on 3.3 volt. If we supply 5 volt to it, there's a good chance we're going to burn the Raspberry Pi or the GPIO pin connected to it. Now let's look at the math behind this. So the echo pin is giving us 5 volt. The input for GPIO needs to be 3.3 volt. We have a formula for calculating this. The formula is V out equals to V in R2 divided by R1 plus R2. R2 is going to be the resistance. So we have 10 kilo ohm resistance. If we're using 10 kilo ohm resistance, we need to figure out what the value of R1 needs to be. Let's put the values into the formula and solve the equation. We know V out, the output voltage needs to be 3.3 volt. The input voltage from the echo pin is 5 volt. And we know the resistance. Let's pull all of that in and we'll get a value of 5.15 kilo ohms, which is similar to 5 kilo ohms. For simplicity, we're just going to say it's 5 kilo ohms. Now let's look into how we can get this 5 kilo ohms using two resistors. In order to get 5 kilo ohms from two 10 kilo ohms resistor, we're going to put them in parallel. When we put two 10 kilo ohm resistor in parallel, the entire resistance of this is going to drop down to 5 kilo ohms. Let me explain how. So the formula here is 1 by R equals to 1 by R1 plus 1 by R2. In this case, R1 equals to R2, which is 10 kilo ohms. So we're going to have 1 by R equals to 1 by 10 plus 1 by 10. This will give us 0.2. If we were to flip side, it's going to be 1 divided by 0.2. That's going to be 5 kilo ohms. This is exactly what we need. Now let's look at the circuit that we'll be using. For this setup, the red wire is the power supply connected to VCC. The green wire represents the trig. The yellow wire is the echo pin coming from the ultrasonic sensor to the resistors. As you can see, as we talked earlier, we're using two resistors in parallel connected to the orange wire that's connecting to the Raspberry Pi. And another 10 kilo ohm resistor is connected to the ground. If you have a 5 kilo ohm resistor or 10 kilo ohm resistor, you don't need to have two 10 kilo ohm resistor in parallel. You could just use your 5 kilo ohm resistor. That would be enough, like previous calculation. But in my case, I only had 10 kilo ohm resistors, so I connected two 10 kilo ohm resistors in parallel in order to get 5 kilo ohm. And the setup is pretty simple. Plug it into your Raspberry Pi and we can look into the code that's going to go into this. I used remote desktop to connect to my Raspberry Pi, so I'm going to log into my Raspberry Pi. Alright, just need to enter my username and password. So the Python code that we'll be using in this video is the same to the Python code we used in a previous ultrasonic sensor video. So I won't be explaining the code in this video. Please refer to the previous video and I will post a link to the code as well as link to previous video. Now you can see after I run the application, you can see that it's working. Every time I move cardboard box, you can see the distance is changing and the distance is pretty accurate to the distance I'm getting from the measuring tape. So right now I've written 20 centimeters, I'm getting 20 centimeters back. Let's move it to 15 centimeters and we have 15 centimeters back. Moving even closer to 5 centimeters and I'm getting around 4 point something back. Even closer now, it's getting kind of weird results because it can't get any signals back, so it thinks it's super far away when it's even pretty close by. This is pretty much it for this video. Let me know if you guys have any questions. Thank you for watching. Please do like the video if you found it helpful. Let me know in the comment section if there is anything I can do to improve the video or answer any more questions you might have. Thank you.